Now in today's class, we will continue with chemical kinetics. In the last class, we had studied about the zero order reaction, the first order reaction. Today we will study about the applications of the first order formula. We will draw the graphs for zero order, first order, second order, and we will study about the activation energy. Now let us start with the application of first order. Now suppose we have to show that time required for 99.9% reaction to complete is 10 times the time required for half of the reaction to take place. Now what we have to show? We have to show that time required for 99.9% of the reaction to take place is 10 times the time required for half of the reaction to complete. That means T 99.9 upon T half is equal to 10. Now we will apply the formula 2.303 upon K is equal to log. जब भी हमें परसेंटेज गिवन है तो हम इनिशियल को 100 ले लेंगे और नीचे क्या होता है, व्हाट इज ए? A is the reactant left after the reaction has taken place. तो 99.9% complete हो गया, इसका मतलब बच कितना गया? 0.1. तो जब हम इसको सॉल्व करेंगे, what will we get? We will get log 1000. And what is log 1000? It is 3. So what we get? We get this. Now let us find out what is T half. T half अभी हमने कैलकुलेट किया था in the previous class. It would be 2.303 upon K log 100 by 50, which comes out to be log 2. And what is the value of log 2? The value of log 2 is 0.3010. So when I take the ratio T 99.9 upon T half, I get 3 upon 0.3, because 2.303 by K is common in both, it gets cancelled. So that means I get 10. So this is how we apply the concept to the formula. अगर आपको बोला है कि 75% of the reaction is complete, इसका मतलब क्या हुआ कि आपके पास कितना रिएक्टेंट बच गया है? 25% of the reaction is left. तो अगर आपको फाइंड आउट करना है T for 75% of the reaction to complete, तो आप बोलोगे 2.303 upon T log 100 by 25. बट अगर आपको बोला है कि after the reaction is complete 25% of the reactant is left, अब आपको ऑलरेडी उतना ही दिया हुआ है जितना बचा है, तो आप अब क्या करोगे? अब आप डायरेक्टली 25 को सब्सटीट्यूट कर दोगे. सो यू हैव टू एंश्योर दैट व्हाट इज द स्टेटमेंट विच इज रिटन इन द रिएक्शन एंड देन अकॉर्डिंगली यू विल सब्सटीट्यूट द वैल्यूज इन द फॉर्मूला. नाउ आई विल एक्सप्लेन यू कि अगर हमें प्रेशर के टर्म्स में क्वेश्चन को सॉल्व करना है तो हाउ डू वी गो अबाउट इट. नाउ एक्सप्रेशन फॉर रेट कांस्टेंट फॉर अ फर्स्ट ऑर्डर रिएक्शन इन गैस फेज. ना सपोज मेरे जो रिएक्टेंट्स हैं और प्रोडक्ट्स हैं वो गैस फेज में हैं एंड दिस इज द इक्वेशन विच इज़ गिवन. तो लेट अस से दैट द इनिशियल प्रेशर इज P0. So after time t, what would be the pressure? It would be P0 minus P, and here it would be P and P, और यहाँ पे initial pressure 0 होगा क्योंकि अभी reaction हुआ ही नहीं है. It is at initial pressure. Now what would be the total pressure after time t the total pressure would be P नॉट माइनस P प्लस P. इन सबको हम ऐड कर देंगे and we will get P naught plus P. Now pressure of, now from here I will find out what is P. P is equal to Pt minus P naught. Now what is the pressure of A after time t? So Pa is equal to P naught minus P, and what is P? It is P naught minus, so that means 2P naught minus Pt. So if I substitute it in the formula for first order, I will get K is equal to 2.303 upon T log. Now what is the initial pressure? Initial pressure is P naught, and what is the pressure after time t? It is 2P naught minus Pt. So this is the expression which I get. Now look at this question which involves the formula for pressure. Now at constant temperature and volume, x decomposes as 2x giving 3y plus 2z, and px is the partial pressure of x, and you are given this table that at a time 0 the pressure is 800, at 100 the pressure is 400, and at 200 the pressure is 200. Now what is the order with respect to x? Since the pressure is changing with time, so that means it cannot be a zero order reaction. So now let us find out that whether it is a first order reaction or not. What we will do, we will substitute the values in the formula for first order. We will find out the rate constant. So कैसे करेंगे? Now K is equal to 2.303 upon T log P naught upon Pt, that is pressure at time 0 upon the pressure at time t. So we will find out K for 100 मिनट्स. अगर मैं 100 मिनट्स पे सब्सटीट्यूट कर रही हूँ तो मुझे टेबल में 100 मिनट्स पे क्या प्रेशर दिया हुआ है? 100 मिनट्स पे मुझे 400 प्रेशर दिया हुआ है, तो मैं इसको यहाँ सब्सटीट्यूट कर दूँगी और मैं जब K कैलकुलेट करूँगी इट विल कम आउट टू बी 6.93 इंटू 10 टू द पावर माइनस 3. और ऐसे ही जब मैं यहाँ पर सब्सटीट्यूट करूँगी, मुझे 200 मिनट्स पे कितना प्रेशर गिवन है? इट इज़ 200. तो इफ़ आई सब्सटीट्यूट, इनिशियल प्रेशर तो मेरा सेम ही रहेगा, एंड व्हेन आई कैलकुलेट अगेन आई विल गेट द सेम आंसर 6.93 इंटू 10 रेज़ टू द पावर माइनस 3. क्योंकि मेरा रेट कांस्टेंट चेंज नहीं हुआ, this indicates that the order of reaction is 1. अब ये तो प्रूव हो गया that it is a first order reaction. Now next part says that you have to calculate the time required for 75% completion of the reaction. इसका मतलब क्या है? यहाँ पर मैं लूँगी t क्योंकि मुझे टाइम कैलकुलेट करना है, k मैं ऑलरेडी कैलकुलेट कर चुकी हूँ ऊपर, एंड log इनिशियल मैं ले लूँगी 100 और 75% कंप्लीशन का मतलब है कि मैं नीचे ले लूँगी 25 और इसको मैं सॉल्व करूँगी आफ्टर सब्सटीट्यूटिंग द वैल्यू ऑफ k विच इज़ गिवन टू बी 6.93 इंटू 10 रेज़ टू द पावर माइनस 3, और यहाँ से मुझे टाइम रिक्वायर्ड पता चल जाएगा फॉर 75% completion of the reaction which is equal to 200 minutes after solving this. यहाँ से जब मैं इसको लूँगी log 4 आ जाएगा. log 4 की वैल्यू को कैसे देखेंगे? log 40 का 0 देखेंगे log टेबल से, which will come out to be 0.602, और जब इसको सब्सटीट्यूट करेंगे the final answer will come out to be 200 minutes. Now let us look at the third part which says that we have to find the total pressure when x is 700 millimeter. अब हम क्या करेंगे? वी विल सी हमारी इक्वेशन क्या है. 2x गिव्स 3y प्लस 2z. इनिशियल प्रेशर मुझे कितना गिवन है? इनिशियल प्रेशर दैट इज प्रेशर एट टाइम 0 मुझे दिया हुआ है 800. यहाँ पे आ जाएगा 0 0. नाउ प्रेशर एट टाइम t, इट वुड बी 800 माइनस 2p, बिकॉज यहाँ पे 2 मोल्स हैं, यहाँ पे 3 है तो 3p और यहाँ पे 2 है तो 2p. तो टोटल प्रेशर विल कम आउट टू बी हाउ मच? It will come out to be 800 minus 2p plus 3p plus 2p, which comes out to be 800 plus 3p. अब मुझे गिवन है कि मुझे टोटल प्रेशर निकालना है when the x is 700. इसका मतलब this is equal to 700. और यहाँ से जब मैं सॉल्व करूँगी प्रेशर will come out to be, small p comes out to be 50 millimeter. तो जब मैं यहाँ पर 50 मिलीमीटर को सब्सटीट्यूट करूँगी तो टोटल प्रेशर विल कम आउट टू बी 950 millimeter. So this is the answer. So this was the application of pressure कि हमें प्रेशर का न्यूमेरिकल कैसे सॉल्व करना है. We have to look at the moles and then accordingly we will subtract. Now we will understand the various graphs for zero order, first order and second order reactions. Now plot of rate versus concentration. Now we know that rate is equal to K concentration raised to the power n. So that means when I plot a graph for zero order reaction, rate versus concentration, what will I get? I will get a line which is parallel to the x-axis, because for a zero order reaction rate does not depend upon concentration. When I plot it for a first order reaction for rate versus concentration, what will I get? I will get a straight line, because the rate increases with increase in concentration. So this is a zero order reaction, this is a first order reaction, and when I plot it for a second order reaction I will have to take concentration square, because rate is directly proportional to the square of concentration. So since it is directly proportional, again I get this line, and this is for a second order reaction. Now we will study the plot of half-life versus concentration for zero order, first order as well as second order. Now let us plot it for zero order. For zero order, the half-life is directly proportional to concentration. Now in case of a first order reaction, the half-life is independent of concentration, it does not depend upon the concentration. जब हमने इंटीग्रेटेड रेट इक्वेशन डिराइव की थी फर्स्ट ऑर्डर की, तो हमने देखा था दैट टी हाफ का फॉर्मूला क्या आया था, इट वाज 0.693 by K. That means it does not involve concentration, it is independent of concentration. Now for a second order reaction, half-life is plotted against 1 by A and it is directly proportional to 1 by A. Now if we plot a graph of concentration versus time for zero order reaction, so we will see that A is decreasing with time, and for a first order reaction we will say that log of A is decreasing with time, and for a second order reaction we will say that 1 by A is increasing with time. So these are the various plots which you have to study. Now we will understand what are pseudo unimolecular reactions. Now let us understand what are pseudo unimolecular reactions. Now the reactions which appear to be of higher order but actually they are first order reactions, they are known as pseudo unimolecular reactions. Now let us take the example of inversion of cane sugar. Now when we study this reaction, we see that sucrose plus water in presence of H plus gives glucose plus fructose. Now what are the reactants here? The reactants are sucrose and water. तो हमें ऐसा लगेगा कि rate should depend on the concentration of sucrose as well as water. But क्योंकि water इतने ज़्यादा excess में ले लिया हमने that it does not affect the rate of the reaction. So that means rate will only depend upon the concentration of sucrose. So that means the reaction is first order. Now let us consider the hydrolysis of ethyl acetate. Now this reaction again takes place in aqueous medium. तो हम क्या करते हैं? We take CH3, COO, C2H5. We react it with water in presence of H plus. We get acetic acid and alcohol. So this is ethyl acetate, this is acetic acid and this is alcohol. Now again we are seeing here that there are two reactants, but again the rate will depend only on the concentration of ethyl acetate and it will not depend upon the concentration of water, because the concentration of water is not going to affect the rate of reaction because the water is present in excess. So again the rate would be K into CH3COO C2H5. So it appears to be of higher order, but actually it is a first order reaction. So these are the examples of pseudo unimolecular reactions. Now we will study what is threshold energy and what is activation energy. Now what is threshold energy? Threshold energy is the minimum energy जो reactants को required है ताकि उनके बीच में reaction हो जाए. अब अगर मैं हाइड्रोजन और ऑक्सीजन को रूम टेम्परेचर पे ले लेती हूँ और उनको मिक्स कर देती हूँ, वाटर क्यों नहीं बन जाता? क्योंकि दे डू नॉट हैव द रिक्वायर्ड एनर्जी फॉर द रिएक्शन टू टेक प्लेस. लेकिन जब मैं इलेक्ट्रिक स्पार्क पास करती हूँ तो क्या होता है? दे गेट्स दैट रिक्वायर्ड एनर्जी, एक्टिवेट हो जाते हैं एंड देन द रिएक्शन बिटवीन देम टेक्स प्लेस टू फॉर्म वाटर. Now what is activation energy? Activation energy is the minimum amount of energy which is supplied to the reactants so that their energy becomes equal to or greater than the threshold energy. तो जो एनर्जी हम सप्लाई करते हैं ताकि रिएक्टेंट्स की जो एनर्जी है वो थ्रेशोल्ड एनर्जी के इक्वल या उससे ज़्यादा हो जाए ताकि रिएक्शन हो सके, उस एनर्जी को हम बोलते हैं एक्टिवेशन एनर्जी. तो जो रिएक्शन रूम टेम्परेचर पर नहीं हो सकते हम उनको हीट करके वो एक्स्ट्रा एनर्जी सप्लाई कर देते हैं या फिर इलेक्ट्रिक स्पार्क दे के वो एक्स्ट्रा एनर्जी सप्लाई कर देते हैं जिससे कि रिएक्शन हो सकता है. नाउ व्हाट इज Arrhenius equation? It is K is equal to AE minus EA by RT. Now what is K? K is the rate constant. What is EA? EA is the activation energy. A is the frequency factor or the pre-exponential factor. It has the same units as K, and R is the gas constant, T is the temperature. So 8.314 joule Kelvin inverse mole inverse, and T is the temperature. If I take log of Arrhenius equation, I will get ln K is equal to ln A minus EA by RT, and if I convert this natural log to the base 10, I will get log k is equal to log a minus Ea upon 2.303 RT. Now, if I say that the rate constant is K2 at a temperature T2 and K1 at a temperature T1, so I can write log K2 is equal to log A minus Ea upon 2.303 RT2 and log K1 is equal to log A minus Ea upon 2.303 R T1, because at the temperature T2 the rate constant is K2, at the temperature T1 the rate constant is K1. Now if I subtract, I say that this is 1 and this is 2. 1 minus 2 करने पर what will I get? I will get log K2 by log K1 is equal to Ea upon 2.303 R 1 upon T1 minus 1 upon T2. So this is the formula which I will get, because log K2 minus log K1 is equal to log K2 by K1. So this formula I will use in the numericals, and I have to ensure अगर activation energy किलो जूल पर मोल में given है तो मैं उसको जूल में convert करूँगी क्योंकि R की value जूल में है, and I will substitute the corresponding value of K2 with respect to T2 and corresponding value of K1 with respect to T1. Now let us understand how I will substitute these values to a numerical. Now let us look at this question. Rate of a reaction triples when temperature changes from 50 degrees Celsius to 100 degrees Celsius. Calculate the energy of activation. Now log K2 by K1 is equal to Ea upon 2.303 R 1 upon T1 minus 1 upon T2. Now क्योंकि आपको लिखा है कि the rate of reaction triples, इसका मतलब K2 by K1 is equal to 3. T1 temperature 1 is 50 plus 273, that is 323 Kelvin. You will change it into Kelvin, and T2 is equal to 100 degrees Celsius, which is 373 Kelvin. Now log 3 is equal to Ea upon 2.303 into 8.314, 1 upon 323 minus 1 upon 373. After substituting all these values and the value of log 3, answer of activation energy would come out to be 22,000 joule per mole. अगर आपको लिखा होता that the rate of reaction doubles, तो doubles में आप क्या करते, K2 by K1 is equal to 2. अगर लिखा होता क्वेश्चन में that the rate of reaction quadruples, quadruples का मतलब है K2 by K1 is equal to 4. Now let us understand how temperature affects the rate of reaction with the help of a graph. Now here we plot the fraction of molecules, and here we plot the kinetic energy. Now what happens is that we get a curve like this. Now this is the threshold energy which is possessed by the molecules at a particular temperature. We get a curve, this is at temperature T. Now this is the threshold energy possessed by the molecules at a temperature T. Now what happens, the peak of this curve, it refers to the kinetic energy which is possessed by maximum number of molecules. Now what happens on increasing the temperature by 10 degrees Celsius, this becomes double. That means the molecules which are possessing the threshold energy becomes double. So that means the rate of reaction will become double, क्योंकि जैसे ही threshold energy को वो cross करेंगे, reaction will take place. So this is the curve which is obtained at T plus 10 degrees Celsius. We have raised the temperature by 10 degrees Celsius. Now this is the kinetic energy which is possessed by maximum number of molecules. Now the interesting thing to note is that even after increasing the temperature, the kinetic energy which is possessed by maximum number of molecules remains the same. That means the number of molecules which are possessing maximum kinetic energy remains same. This area, if you see, has become doubled. Now the interesting thing to note about this graph is this peak is the most probable kinetic energy which is possessed by maximum number of molecules. So even after increasing the temperature, the fraction of molecules which are possessing most probable kinetic energy will remain same, but on increasing the temperature by 10 degrees Celsius, the molecules which are possessing threshold energy becomes double. So that means the rate of reaction will become double. Now let us understand the effect of catalyst on rate of reaction. Now what does catalyst do? Catalyst increases the rate of reaction. Now how does catalyst increase the rate of reaction? By lowering the activation energy. That means after adding catalyst, the reaction follows a different path. That is, now it requires low activation energy. So let us see, these are the reactants and these are the products. Now what happens is that this is the energy barrier. Let us say this is uncatalyzed reaction and this is the catalyzed reaction. So now this catalyzed reaction, it requires lower activation energy. Now if this is the activation energy which is required by a uncatalyzed reaction, so this is the activation energy which is required by the catalyzed reaction. So that means after adding catalyst, the activation energy gets lowered, the reaction follows a different path, and that is why it becomes fast. Now let us understand this with the help of a numerical. At 27 degrees Celsius, in the presence of a catalyst, the activation energy of a reaction is lowered by 2 kilocalories. Calculate by how much the rate of reaction will increase. So after adding the catalyst, the activation energy has lowered and we have to find out कि rate कितना increase होगा. Now for uncatalyzed reaction, I will write that log K is equal to log A minus EA upon 2.303 RT. But now for catalyzed reaction, let us say that the rate constant is K prime. So it becomes log A and activation energy becomes EA minus 2. So EA minus 2 upon 2.303 RT. Now let me subtract log K prime minus log K. So I will get, after rearranging, 2 upon 2.303 RT. Temperature I have been already given in degree Celsius. I will convert it into Kelvin. R की वैल्यू मैं डालूंगी 2 into 10 to the power minus 3 kilocalorie Kelvin inverse mole inverse. बिकॉज मुझे एक्टिवेशन एनर्जी की वैल्यू गिवन है 2 किलो कैलोरी, इसीलिए मैं यहाँ पर R की वैल्यू भी किलो कैलोरी में डाल रही हूँ। और ये कैसे आया? आफ्टर सब्ट्रैक्टिंग these two equations, after rearranging, I have got this. Now log k prime by k after solving will come out to be 1.447. लेकिन मुझे तो क्या निकालना है? I have to find out k prime by k. That means मुझे एंटी लॉग देखना पड़ेगा for 1.447. और मैं एंटी लॉग कैसे देखूंगी? ये जो है ये 10 की, ये डेसिमल से पहले 10 की पावर में चला जाएगा 1, और जब मैं एंटी लॉग टेबल में देखूंगी 0.447 की वैल्यू I will get 2.8, so my answer will be 28. तो 28 times rate of reaction will increase if the activation energy decreases by 2 kilocalories. So today we have studied about first order reaction numericals, activation energy, how the rate of reaction increases on increasing the temperature, the numericals based on activation energy. Questions related to these concepts are given in the module. Solve these questions. Thank you. God bless you.